Hello friends, in this video we are going to discuss about the magnetic force. Under magnetic force we will study about the concept of magnetic field. So as we all know, the static charge will produce the electric field around it. If suppose you place any charge in the field of this charge, then this charge will experience the force, right? Electric force. So this static charge will apply certain amount of force when it is under its boundary. So therefore even this charge will experience the electric field. Similarly, just as a static charge produces an electric field, conductors carrying current or the moving charges produces the magnetic field, which is denoted by capital B. Okay, so here the magnetic field disappears. This is very important. The magnetic field will disappear as soon as the moving charges will stop. When the moving charges will stop, the magnetic field will vanish. Okay, so what does it say? It says that only the moving charges will produces the magnetic field. Only when the current is flowing through the conductors, then only those conductors will produces the magnetic field, right? So this magnetic field is the vector quantity. It have the directions. Okay, so when we say vector field, what does it mean? It have both dimensions as well as the directions, so we called it as vector field. Okay, so it have several properties which is identical to that of the electric field. So magnetic field have the properties which are identical to the electric field. The exception property here is that in the electric field what we have is the electric field lines does not forms a closed loop, whereas the magnetic field forms the closed loop. In my previous video I have explained about the properties of magnetic field. In that you might have seen, if suppose this is the bar magnet and this is north pole and the south pole of the bar magnet, the magnetic field will start from the north to south, and inside the bar magnet it goes from south to north. Okay, so it will form the closed loop. It does not have any starting point or the ending point. And one more important thing you have to note, that the magnetic field obeys this principle of superposition. This is also very important. It obeys principle of superposition. What does it mean? If suppose you have large number of fields in a space, okay, suppose you have several sources in the several sources, so the magnetic field at a point, due to that several sources, suppose you have B1, B2, B3, okay, there are number of sources which is producing the magnetic field. So what does the principle of superposition says? It says that the magnetic field be at a point. Okay, suppose this is a point, the magnetic field at a point due to several sources is the vector sum of the magnetic field of each individual sources. Okay, what does it say? The magnetic field at a point due to the several sources is the vector sum of magnetic fields of each individual sources. So mathematically we can write it as vector B is equals to B1 plus B2 plus B3 plus so on. So this is the principle of superposition. So here where B1, B2 and B3 are the magnetic fields at a point due to each individual sources. Okay, hope you have understood this. So here as I told, the magnetic field has similar properties like the electric field, except that it forms the closed loop, okay, closed path without a starting or the ending point. If suppose the magnetic field is emerging out of the plane, okay, if suppose this is your plane and magnetic field is emerging out of the plane, then it is denoted by dot. Okay, this is denoted by dot. If suppose it is the magnetic field is going into the plane, then it is denoted by cross mark. See, if how will you remember this? If suppose you have arrow, okay, arrow mark, which is like this. Now when you see arrow, how will you see the tip of this arrow? You feel it to be dot, since it is sharp. So therefore whenever it is coming out, the arrow is coming out of the paper, what you see is a sharp point, right? What you see, a sharp point, that is a dot. So therefore we write here dot. When it is going inside, we see this cross mark. Okay, when it is moving inside, you have to note that we see the cross mark. So therefore out of the plane and this is into the plane. Hope you have understood what is the concept of magnetic field. Now what is magnetic force? Okay, here in the next, magnetic force on a moving charge. Okay, so that is also known as Lorentz force. So let us understand what is a magnetic force on a moving charge. Suppose you have one plane. Okay, let us consider this is the plane and we have the charge which is at point P, point this, and we have a positive charge. Okay, suppose this is the direction of the magnetic field, that is vector B, and this is the direction of the direction in which the charge is moving with a velocity v, and the force will always be perpendicular to both B and V, and the angle theta is formed between B and V. Okay, so force is perpendicular to vector B and vector V, that is magnetic field and the velocity, whereas the force is perpendicular to both this, and the theta is the angle formed between magnetic field and the velocity. Now here the magnitude of the force, if you want to find the magnitude of the force, magnitude of force, so magnitude of the force on the charge q which is moving with a velocity v in the magnetic field B, okay, is given by F is equals to q v cross B. Since they are perpendicular to each other, we write it as v cross B. Okay, if it is a cross product, we know that we can write it as VB sine theta. Okay, let us consider this as equation 1. So hope you have understood the force here, the force due to the charge q which is moving with a velocity v under the magnetic field B. So that is given by V into V cross B is written as VB sine theta. Since it is a cross product, we write it like this. Now here we can say that theta is the angle between the direction of vector B and V and vector B. So if suppose I say that F is equals to B, when this is satisfied, when is our force is equal to the magnetic field? Force is equal to the magnetic field when we have the positive charge, positive unit charge, which is moving with a unit velocity. We have a positive unit charge which is moving with a unit velocity and perpendicular, that is the angle between the B and the V is the 90 degree. That means it is moving perpendicular. Okay, so therefore we can say that the magnetic field B at a point, okay, at a point is defined as the force acting on a unit positive charge moving with a unit velocity perpendicular to the direction of the magnetic field. So this is the direction. When it is moving perpendicular to the direction of magnetic field, we say that F is equals to B. Hope you have understood this. Now one more thing, one question will come for 1 marks, that is, what is the unit of magnetic field? SI unit. The SI unit of magnetic field is Tesla. Okay, what is it? It is Tesla, denoted by capital T. So therefore the definition of Tesla, how can you say this is B, right? So this is your Tesla. So if you want to define the definition of any unit, always remember in the equation you have to equate everything to be unity, then you will get the definition of that particular unit. So therefore in order to define Tesla, what you can do is, see, how will you define the magnetic field at a point? The magnetic field at a point is 1 Tesla, is 1 Tesla. This is 1, okay, 1 Tesla. When it is said to be 1 Tesla, if a unit positive charge of 1 coulomb is moving at right angle to the magnetic field with the velocity of 1 meter per second, experiences a force of 1 Newton. So therefore when I say F is equals to B, that is 1 Newton is equals to 1 Tesla. When it is so, when the unit positive charge, that is plus Q, is moving with a velocity that is 1 meter per second and it is moving at a perpendicular angle to the force. Okay, so therefore that defines your Tesla. So we can say B is equals to 1 Tesla if your Q is equals to +1, and that is Coulomb is the charge of the unit of charge, and V is 1 meter per second, and theta is equals to 90 degree. Therefore your force will be equal to 1 Newton. Hope you have understood this. So here Tesla, the relationship between Tesla and another unit of magnetic field, that is Gauss, is 1 Gauss. This is also important relationship. It can be asked that 1 Gauss is equals to 10 raised to -4 Tesla. Okay, note down that 1 Gauss is equals to 10 raised to -4 Tesla. Now, if suppose they ask you in a question that what is the dimensional formula for Tesla? Okay, what will be, how will you find the dimensional formula for Tesla? See, we have that F is equals to Q VB sine theta, right? If you want B, then we write B is equals to F divided by QV sine theta, right? You can write it like this. Now, the dimensional formula for B, you can write it in the square bracket as, we know the dimensional formula for force is F is equals to ma, that is mass and acceleration. So it will be m raised to 1 L t raised to -2. This I have taught in my previous class. You can go through it. Then we have here Q. We know that current flowing through a conductor is equal to charge per unit time, right? So therefore from here, if you want Q, it will be I into T. The dimensional formula for I is current is ampere, that is A, and T is capital T. So therefore from this you can write the Q as A into T, and V we have, V is what? Velocity, that is LT minus 1. This is trigonometric value, so the dimensional equation does not give any value for the trigonometric equations. This is one of the limitation of dimensional analysis. Okay, it does not give any unit for sine theta, so we discard this. So here after solving this, what will you get? That L and L will get cancelled. Okay, if this T will move up, what will we get is M A, okay, A raised to, then we have here T, that is T raised to -2. Okay, what do we get? We get it to be M, L get cancelled. Okay, solve this. T got cancelled. We have here A raised to -1, T raised to -2. So this is your dimensional equation for B, that is magnetic field. Hope you have understood what is the formula for dimensional formula for magnetic field. So if suppose the positive charge is moving, okay, if the positive charge is moving, listen very carefully, if the positive charge is moving with a velocity v in the presence of both electric field and magnetic field, in the presence of both electric and magnetic field, then the force on the charge due to both the fields will be F is equals to Q into E plus Q into V cross B. That is, this is force of electric field and this is force due to the magnetic field. Suppose if the positive charge is moving with a velocity v in the both electric and magnetic field, then force will be equal to QE plus Q into V cross B. So how can you write this? We can take Q common. Here we have E plus what is remaining here, V cross B. So therefore this equation, this particular equation is called the Lorentz force. What it is called? It is called as Lorentz force. The Lorentz force only in the magnetic field. If you want to find the Lorentz force only in the magnetic field, it will be F is equals to Q into V cross B. Hope you have understood what is Lorentz force. In our next video, we shall be discussing about cyclotron. Okay, this is also another very important topic. Then we have solenoid, then we have toroid. This everything will cover in my next upcoming videos. Hope you have liked the videos. If you like the videos, please hit the like button and don't forget to subscribe to my channel and share with your friends. Hope it will be helpful for all the aspirants of GPSTR and HSTR. Thank you friends for watching.